Assalamu alaikum. In today's video, we're not going to look at any exercise, but we're going to look at the task that has been provided in this chapter. It is actually an extension. It is for those students who are going to pursue computer science in their A levels or are interested in this. So, the first topic includes logic circuits in the real world. So, what they're trying to talk about here is that um, समटाइम्स यू कैन से कि फॉर एग्जांपल अगर एक ये गेट्स होते हैं, ये गेट्स फिजिकली अवेलेबल होते हैं जब इनको कहीं ना कहीं यूज़ किया जाता है इन गेट्स को। तो कभी कभार होता है कि आपके पास ये गेट होता है, ये गेट नहीं होता, या कुछ गेट्स शॉर्ट होते हैं मार्केट में, ठीक है। तो उस केस में हम क्या करते हैं कि दो तीन कोई और गेट्स लेके, जैसे फॉर एग्जांपल अगर मेरे पास एंड गेट अवेलेबल नहीं है तो मैं उसकी जगह और गेट के कुछ कॉम्बिनेशन ऐसे बनाऊंगी कि उसकी आउटपुट जो है वो एंड गेट की प्रॉपर्टी को अप्लाई कर रही हो। या फॉर एग्जांपल अगर मैं लूँ एक, कि हमें पता है नॉर क्या करता है। नॉर इज बेसिकली नॉट एंड ठीक है। और हमारे पास नॉर गेट नहीं है अवेलेबल, तो हम नॉट और वाला गेट यूज कर सकते हैं, नॉट वाला और साथ में और वाला गेट को यूज कर सकते हैं, और हमारे पास वो नॉर का फंक्शन परफॉर्म कर रहा होगा। सिमिलरली अब यहाँ पर उसने हमसे जो है क्वेश्चन जो किया है, उसने हमें कहा है कि हम लोगों ने इस दफा नैंड गेट को देखना है। उसने कहा है कि ये जो एंड गेट जो है, ये दोनों नैंड गेट्स जो है ये एंड गेट की प्रॉपर्टी अप्लाई करती हैं। फॉर एग्जांपल हमारे पास एंड गेट नहीं है, हमारे पास नैंड गेट अवेलेबल है, तो उससे हम लोग एंड गेट की फंक्शनैलिटी कैसे परफॉर्म करेंगे, वो इस लॉजिक सर्किट के थ्रू परफॉर्म हो सकती है। सिमिलरली इस लॉजिक सर्किट के थ्रू हम लोग और गेट की फंक्शनैलिटी यूज कर सकते हैं विदाउट यूजिंग और गेट। सिमिलर इन दिस केस हम यहाँ पे नॉट गेट की फंक्शनैलिटी यूज कर सकते हैं विदाउट यूजिंग द नॉट गेट। सो in the question, the task 1 says draw the truth table, show that the three circuits in figure 10.34 can be used to represent and or and not gates। अब हम लोगों ने इनके जो है वो बनाने हैं, ट्रुथ टेबल बनाना है टू सी कि अच्छा क्या ये एक्चुअली सही थी लॉजिक या सही नहीं थी। सो लेट्स डू द टास्क 1। Okay, so I just made some truth tables. So firstly we are going to look at the AND gate. We have A and B as the inputs. So I just wrote A and B as the input 0 0 0 1 1 0 and 1 1. These were the possible combinations of these two inputs. And now we have to, this is the output F. So output F includes, this is the NAND gate, right? So NAND gate property is going to be applied. So A dot B, when there is 0 dot 0, it should be 1. So we will write 1. 0 dot 1, it should be 1. 1 dot 0, it should be 1. And when there are both 1s and we are solving using a NAND gate, it is going to become 0. Now what is going to happen is that we have F as the input, and F, the second input, is also F. Both of the inputs are of F. So in this case what will happen, we will have a NAND property that will be applied. So that means 1 dot 1. 1 dot 1 is going to be 0. 1 dot 1 is going to be 0. 1 dot 1 is going to be 0. 0 dot 0 is going to be 1. So that will be the X. Now I want you to see that if we have to do an AND gate property, apply AND gate property on A and B, what will happen in this case? 0 and 0 will give us the answer 0. 0 and 1 will give us the answer 0. 0, 1 and 0 will give us the answer 0. And 1 and 1 will give us the answer 1. So in this case, if we see that the answers we are getting from X are the same as A dot B, so it does not matter even if you use two NAND gates in this particular manner, the answer will be the same exact one as we will get from an ordinary AND gate. So instead of entire this, if we use something like this, it is also sufficient. Okay, so now for the OR gate, it's similar thing. Let's solve the OR gate first this time. 0 plus 0 will be 0. 0 plus 1 will be 1. 1 plus 0 will be 1. And 1 plus 1 is going to be 1 as well. So let's solve this part. A and A, both of A are the both inputs. So A dot A, we have to do a NAND of A. So A 0 dot 0 will be 1. 0 dot 1 will be 1. 1, 1 dot 0 is going to be 0. 1 dot 1 is also going to be 0. Right? So, sorry, 1 dot 1 and 1 dot 1 here as well. So the answer is going to be 0 in this case. For G part, again we have this B as the both inputs. So 0 dot 0 is going to be 1. 1 dot 1 is going to be 0. 0 dot 0 is going to be 1. And 1 dot 1 is going to be again 0. So, right, that's so far. Now, for F and G, both are the inputs of the X NAND gate. So, F dot G, 1 dot 1 is going to be 0. 1 dot 0 is going to be 1. 0 dot 1 is going to be 1. 0 dot 0 is going to be 1. क्योंकि हमारे पास 0 आ रहा है. So, whenever we have a 0 in NAND gate, that means the answer is going to be 1. So if we match both of the inputs after the x1 and the a plus b which we already got, we're getting the same results. Now for the NOT gate, we have a complement which is the NOT gate. What will happen? 0 है तो यहाँ 1 हो जाएगा, 1 है तो यहाँ पे 0 हो जाएगा. So now a and f is also the same inputs as a, because f is basically the part of a. So it's going to be 0, it's going to be the 1, and the x is going to be the NAND of a dot f. So 0 dot 0 is going to be 1. 1 dot 1 is going to be 0 if we apply the NAND properties here. So that's how we can show that how these three circuits that were shown here can be used to represent and or not gates, because it is confirmed using the truth table as well, and we have compared the values as well. So that's it for task 1.